Example 3. An educator wishes to examine whether grade level and gender have any effect on students' vocab scores. We've got 4 grade levels: freshman, sophomore, junior, and senior. And before we start solve the problem, let me go load the data set. To load the data set, I have a code written in SAS. I uploaded this file into this place, inside this folder, and I would like to run this code. I run the code, I'm going to see a library name called stats has been created, contains many data sets. So I'm going to run this. And I can go to libraries, library, there is a stats library, and I care about high school data set. Double click on this. Let me close this. So this is my data set. So we have grade, we have gender, we have vocabulary score, we have spelling score, English score, honor, yes or no. Know that this is categorical. This is a numeric, continuous, numeric, continuous, numeric, continuous. This is also categorical, nominal, yes or no. It's binary actually. So the grade, we have 4 levels: freshman, sophomore, junior, and senior. For gender, we have 2 binary, male and female, 2 levels. And this is, as we said, these are 3 variables. These are continuous. We don't care about spelling score right now, English. We just want to look at the vocab score. This English comes from both these two, I guess, like an average or something like that. But we're going to speak about this later. Now let's focus on the English, on the vocab score. So the question is, we would like to see how grade and gender, how both together affect that score, the vocab score. So this problem, actually, we have 3 variables. We don't have one. So before we specify the goal, let me just set up the variables, because we're gonna kind of realize what kind of things that we have before we decide. So we have the grade level. This is categorical, nominal. It's an independent variable, right? Dependent variable. So have the gender. This is also categorical. It's nominal. It's independent. It's binary. It's binary. 2 levels. This one contains 4 levels. This one has only 2 levels. Binary. Okay. The third one, which is the vocab score. This is continuous, numeric, and this is a response variable. This is the response variable. This is response variable. So the question is, we are not studying only the gender, studying the difference in the scores for, based on the gender, or if there is a difference in the scores based on the gender. No. Or if we are studying only if there's a statistical difference in the means of the scores across the gender, then we are talking about independent t-tests, right? Because this is continuous, this is binary, 2 categories, then it's a t-test. Also, we don't study the vocab scores, the difference, if we have a difference in the vocab scores based on or across the grade level, 4 levels. In this case, we're talking about one-way ANOVA, because we have one factor here with 4 levels, and we have continuous, then we are talking about one-way ANOVA. But in this case, we are studying the 2 factors. If these 2 factors have any kind of effect on the vocab score, these 2 categorical independent variables and one continuous numeric score, then we are talking about two-way ANOVA table. Two-way and not table, two-way ANOVA. Two-way ANOVA. Why two-way? Because we have 2 factors. Factors. 2 factors. What are the factors? Grade level is the first one. Grade level. This contains 4 levels. Second factor is the gender. This also has 2 levels, right? So we have 2 factors, and we are studying the effect of these two. We have a differences in the means and how these 2 factors act with each other and how they affect the newest variable, which is the vocabulary score, right? So to do that, we are going to specify the goal. The goal is we are not just studying how the grade affect or how the grade by itself, how the gender by itself, and how the both of them interact together. So the first one, we know how to deal with it, like to determine whether students different grade levels differ in mean vocab scores. The first one and goal is to determine whether males and females or gender differ again in their means vocab score. Finally, we'd like to determine whether the relationship, whether the kind of relationship, we may say, between a grade and vocab scores changes on gender. These are maybe the three objectives that we are trying to achieve. This one we are trying to say, the last one is the interaction term, which is, does one gender respond differently across the grade levels than the others? This one is going to be to determine if one gender respond differently across the grade levels than others. So this is the interaction term. So because we have two categorical variable, one continuous, and interaction term that whether variables have an effect on that continuous variable, then we are thinking about two-way ANOVA. Do two-way ANOVA, that means we are going to set up multiple hypotheses, not just one hypothesis. So the first hypothesis is going just to be for the grade level. So we're going to study how the grade level, or if there is a difference in the scores for different grade levels, number one. Number two, we are going to look at if there is a difference in the scores between different genders. And the last one, we're going to study whether the interaction term, like if there's an interaction effect between the grade levels and gender on the vocab score. So the first one, we are going to do something that we know already, which is hypothesis. Let me write it. Let me put level. This is the first one. So the first hypothesis, which is H note, mu for a freshman is equal to the mu for the sophomore, equals to the mu of junior, equals to the mu of senior. Okay, senior. What does this mean? I'm going to try this in English, that H note, there is no difference. There is no difference in mean vocab score across for the grade level. So they are all equal on average. Okay. The alternative hypothesis, on the other hand, at least one grade level mean vocab score is different. They are not all equal. They are not all equal. Okay. They are not all equal. Okay. Or at least one of them is significantly different from others. This is the first hypothesis. The second hypothesis is going to be related to the gender, only the effect of the gender, or if the gender has any gender. And I am going to copy this, and I'm going to change this because of the... So female versus male. So the female and male. Mean of the average of the vocab score for the males is equal to the average scores of the female. In other words, there is no difference in mean of the vocab score across between female and male. And the alternative hypothesis is that can say these are not equal. They are different. It's similar to the t-tests. How to write this? There is a difference. There's a difference in the mean score and the mean vocab scores between male and female. The third hypothesis, which is the new one, which is we are studying the interaction term, which is the grade level. Let's call it interaction. Grade times gender. And we are going to interpret the results. What is the null hypothesis? The null hypothesis, there is no interaction between grade levels and gender on vocab score. This is the default scenario. However, for alternative hypotheses, there is an interaction between grade levels and gender on vocab score. What does it mean by this interaction term? That the H note, we say there is no interaction between grade levels and gender on vocab score. Actually, the question for the interaction hypothesis that we are asking whether do we have a difference in mean vocab score and the average vocab scores across the grade level? does this one depend on whether you are a male or female? Or you can flip it. You can say, does the difference in mean vocab scores between males and females this depend on which grade level you are in? And the null hypothesis, what we are saying, we are trying to say that there is no interaction between grade level. We don't have any interaction between grade levels and gender on the vocab score. What does this mean? For example, if juniors score higher than freshmen, this is going to be true for both male and female. Or if sophomore scores lower than seniors, this is going to be true again for both male and female. So every time we're going to say the same exact story, whether we are looking for the female or male. However, for the interaction, I mean, for the not for the alternative hypothesis, what we are trying to say that there is an interaction between the grade levels and gender on vocab score. So that pattern across the grade level is different for female and males. Again, if we take just simple example, suppose that the females improve, I mean, from freshman to junior, but males show almost no change. Or maybe males score very high when they are a freshman, but decline sharply. However, females do the opposite. So the story of how scores change from a grade to grade is different story depends on the gender that we're looking for. If the interaction exists, that means, oh, we do have a different story. Okay, so what to do now? We're going first to check the assumptions. What assumptions are needed for two-way ANOVA? The assumptions that needed for the two-way ANOVA, 4 assumptions. Number one, the independent of the observations. And this is by design. This is by design. And we mentioned this multiple times. Each student's vocab score is unrelated to any other student. There is no overlap between the groups. The other assumption that we would like to check is the normality. Actually, is the first one, the normality. And this is going to be checked using histogram of the residuals or QQ plot. And we are expecting to see something bell-shaped, symmetric. Third one, which is the variances are equal, and we can see that one using the residual versus predicted value plot. Finally, the groups have to be equal in the sample size, and we can see this. We have a balanced design. So let's check this quickly. I'm going to go to tasks and I am going to go to, let me try summary statistics. SAS high school, tab score is my variable, and I'm going to use two classification variables I'm going to run. We have 50 each, 50 in each group because we have 8 different groups. Female 50, freshman male 50, junior female 50. So it's a balanced design. It's a balanced equal cell size. And let's go back. Let me close this. So this is also by design. We have equal. So this is met, dependency met. Then we have to check the normal distribution and the variances of the population. They have to be equal. So what we're going to do, I'm going to close this. I'm going to go to way ANOVA. We have the high school. My dependent is the vocab. I have 2 factors. I'm going to choose these 2 factors. And I'm going to go to model. I'm going to edit, add these 2 factors, full factorial. Full factor, the effect of the first one by itself, the second one, then the interaction term, then okay. Then I'm going to go to options and I am going to look at statistics additional to keep the main effect 2 keys Kramer if we have a differences. Level is 5%. Some of the squares we have type 1, type 3. We check type 3. There's no need to show, type 1. The default plots, I'm going to select plots and I'm going to select diagnostic plots. I'm going to keep them as a panel of plots. And I am going to take off the mean difference plots. And I'm going to run this. Okay, at the beginning, if you look at the very first table, what we see, We see the class level information. We have the grade. We have the grade factor. We have 4 levels. The gender. We have 2 levels. We have 400 observations. All of them are used. And if you look at the assumptions, the first assumption that we would like to look at is whether we have a normality of the residuals, the normality of the residuals. To do that, we can look at the residual histogram. This is almost roughly bell-shaped. Also, this one is important, the residual versus the quantile. And all of the points, most of the points are following that diagonal reference line. So in this case, this is kind of coming from a normal distribution. Then the normality test is passed. That we look at these if we have equal variances across the groups or no. We look at the residuals versus predicted value, or we can do the Levan test, by the way. But let's look at this chart, and this is enough. The residual versus predicted values. What we're expected, we're expected that 2, 3, 4, 5, 6, 7, 8, 8 groups, and we are expected each of these groups to be kind of roughly distributed evenly, around the zero. So, I mean, half of them have to be there up, half of them have to be down. We are expecting to have kind of the same variance. And if you try to look at the upper bound, the lower bound, almost we have the same variance. So we don't have a different variances. We have a few values here, but that's okay. Generally speaking, we don't have any specific shape. They're just equal. So again, we are also there is no pattern. They are spread fine. I mean, so the variances look equal across different groups. But we are done from what's so called the assumptions. After that, let me go back and look at, as I said, we have these observations, 400, and all of them are used, right? Then what we look at the first, the ANOVA table, which one has the model and the error and the corrected total. And we look at the p-value. This is the overall model. The overall model, is it significant or no? This is the question that this table is answering. Is the overall model statistically significant? The answer is yes, because the p-value is very small. Does it mean altogether, the grade level and gender, both of them are significantly associated with differences in vocab scores, period. And if you look at the R squared is 15%. What does it mean? It means that about 15% of the total variation of the vocab score is explained or accounted by grade level and gender. This for the R squared. So from this table, we look at the overall model significant. We look at how much is explained by the model. So if you notice that we have type 1 sum of the squares, we have type 3 sum of the squares. These are two different tables. They look the same right now because right now we have equal balance, or we have balanced design, 15 each group. So we have 8 groups, so we have 15 each group. That's why they look exactly the same. But if you have, unbalanced groups, then you're going to have technically different sets, different two tables. Anyway, there is a conceptual difference between type 1 sum of the squares and type 3 sum of the squares. We're going just to focus all the time on the type 3 sum of the squares. And before we start reading, again, we are focusing on the p-value, but we don't treat the first or the second one first. No, we read the interaction first. We look at the interaction first. In this case, we have the interaction. The p-value is big. So we fail to reject the null hypothesis. Failing to reject the null hypothesis. So when you fail to reject the null hypothesis, what you are saying that there is no significant interaction between grade level and gender. Or we don't have evidence to say that there is an interaction. There is no evidence to say that, right? There is no evidence to say that. And by the way, versus gender, we don't have interaction terms. So they don't tell different stories, one if you know one and you want to check the other one. But they have actually, if you look at each, there is a significant difference. This is less than 0.005. The grade level and the gender is also significant, both of them. I will be back to these just a second. So the gender and the grade, we don't have sufficient evidence to say that there is an interaction between grade level and gender on the vocab scores. And this is supported by this line. This line, how do we read this? How do we read this line? This is of the freshmen for male and female. Scores are for the juniors, raw scores, males and females. This is the raw scores for the senior again, and this is the sophomore, the same thing, right? And these are matching or connecting the mean, the averages for the female and male. The blue one is for the female, and the red one is for the male. And if you look at the first two lines, both lines rise sharply, the freshman to junior, right? The mean vocab scores increase for both males and females as they move from freshman to junior. And it happens for both genders in the same direction. Then what happens? Both lines slightly decline. Both lines, they behave the same. Decline from junior up to senior, right? And actually onwards up to sophomore. But let's stop here. Both males and females, we have a small drop in the mean scores, and it happens for both genders, same direction, right? And last one, uh, the senior from senior to sophomore, the males decline, and the gap becomes more actually between males and females. Look at the lines; they have never intersected. They have never intersected. They're kind of because look, these two lines have to tell one out of two stories. Either they're going to be parallel or they're going to cross or diverge, right? They are parallel, like in this case, they're not crossing each other, then we have no interaction. So, like the grade works the same way for both genders. But if you have an interaction, then the grade works differently depending on the gender. In this case, because they have not interacting, I mean, they are not crossing each other. They're kind of roughly parallel, right? That's why we said there is no interaction. Now, what about we back now to the grade? So we do have a statistical difference in the mean vocab scores across the grade levels because the p-value less than 0.0001. So we do have statistical difference in mean vocab score across levels, across the grade levels. So question is, by the way, if you have a statistical difference, so this is hypothesis number one. We do have we reject null hypothesis. At least one of the grade level mean vocab score is different. Which one is different? We look at Tukey. So we look at Tukey. Where is Tukey? The grade level. This is Tukey. This is Tukey for the grade level: freshman, junior, senior, sophomores. These are the averages, the means. Least squares means, but we don't have missing values, so they are just the same as the means. And this is the table of the differences, the p-values, right? These are the p-values. So freshman, junior, freshman, here, 1 and 2, statistically significant. We do have a difference in the mean scores. And 3, freshman and senior, we do have statistical difference. 1 and 4, we do have statistical difference. So freshman across all of the others, we do have statistical difference. However, the rest, this one, we don't have statistical difference. 2 and 3. Junior, senior, we don't have any changes. And 4, we do have statistical difference in vocab scores, so on. So we can actually study which ones have statistical difference and which ones are not in terms of the vocab scores. The same is applicable to what? To the gender. Go back to the gender. We said that we rejected the hypothesis. What does it mean? There is a difference in mean vocab scores between male and females. So there is a statistical difference. We don't look at the Tukey because we have only two categories. So we say that there is a significant difference, then we are done. We do have a significant difference between these two. So this is almost everything that we want to talk about. And these are the versus the mean score. These are the confidence intervals. You can see them here, by the way. Between 74 to 81, 94 to 101, 02, etc. So this is the whole story. And to write the conclusion, we have to write a very long conclusion. So I'm going to actually pause. So, it takes a long time to write. Then I'm going to just show you the very last product. Okay, so this is the conclusion. A two-way analysis of variance was conducted to examine whether mean vocabulary scores differed across grade levels. All of the assumptions were satisfied. Actually, we should have actually mentioned the details within the assumptions, not in the conclusion. but we have to do that here. What we found that the interaction between a grade level and gender was examined first. Again, this is important. We have to do the interaction first. The results showed that the interaction was not statistically significant. We reported the F value and the P value. What does this suggest? The vocab score differences across grade levels was consistent for both male and females. We didn't have an interaction. And this was supported by the plot. The plot is important. As I said, the plot shows approximately kind of parallel behavior between, both genders, okay, for both genders. And because we have non significant interaction, but still we have main effects. And these are, by the way, we call them the main effects. This is the main effect, is the second main effect. So we do have main effects. We found that there is a main effect. And there was a statistically significant difference in mean vocab scores across the grade levels. I reported, as usual, the F value and the P value. To know that, where are the differences? We conducted post hoc comparison 2 key tests, found that the freshman student had significantly lower mean compared to the junior and senior and sophomore. But the mean vocab scores did not differ significantly between junior and senior, okay, between senior and sophomore. Also, we found that there is a statistical difference between the mean scores between the two genders, male and females. And we found that the females scored higher than the males' scores. I reported here the some papers they report the confidence interval. We can try to do that from time to time, reporting the confidence interval, but it's clear that the female scored higher than the male. This is 92%, this is 87% for the male, 90, this is for the 95% confidence interval. And we reported the overall model. The overall model accounted for about 15% of the variance in the vocab scores. R squared is about 0.515, and the F value, which is, and the P value. Finally, we summarized what we found, just in plain English. Grade level and gender were each independently associated with a significant difference in the mean, because we didn't have independently, it's important. We didn't have interaction terms, okay? There is no interaction term. And we talked about, again, the freshmen, scored lower than others and so on. So we just repeated this without having some stat and metrics. So this is everything about two-way ANOVA.